It was 11 p.m. and I was up late radio tracking lizards on a remote tropical floodplain in northern Australia. It was hot, the insects were incessant, and I was tired and I wanted to go back to base. But as I'm driving back, I hear a sound that no ecologist wants to hear. It was the sound of a male cane toad calling from a water body somewhere in the darkness. And it gave me goosebumps because it was the arrival of the cane toad's invasion at my field site. And I knew that the stakes were high now, not just for the animals that I was studying or my PhD, but for the whole ecosystem. I'm Dr. Georgia Ward-Fear. I'm a conservation ecologist and a postdoc at Macquarie University in Rick Shine's lab. I have also been working with cane toads for nearly a decade. Cane toads are a large body aneurin species native to South America. They were introduced in the 1930s into Australia to control pests of sugarcane fields. They were introduced as a biocontrol, but they didn't do that. Instead, they spread. Females are highly fecund. They can lay 30,000 eggs twice a year. So in terms of a system of invasion, they resemble invertebrate invasions more than vertebrates. And cane toads also produced a really potent toxin from glands on the back of their neck. And this is bufotoxin, specific to the toad family. Because Australia has no native toads, our wildlife are extremely susceptible to this toxin, and they only have to mow the toad for, say, 10 seconds before they die. Not many animals are directly impacted by cane toads in Australia, but they do still wreak ecological havoc. And that's because the animals that are impacted are the apex predators, the animals that sit at the top of the food web and regulate interactions below them. We've seen huge declines in these species across their range, and that has sent ripples through the ecosystem. So preserving these species is not just important for the species themselves, but also for maintaining the integrity of the tropical ecosystems that they manage. But how does an Amazonian rainforest species adapt to the Australian continent, which is so different? Well, the answer is surprisingly well. Since cane toads have arrived in Australia, they have rapidly evolved adaptations to not only invade, but also thrive across the Australian continent. They've penetrated into far more arid areas than we ever could have thought, and they do show adaptations to arid environments and the cold climates there. In the southern invasion front, we see an adaptation to high altitude mountain ranges, as well as the extremely cold temperatures that they experience. But the northern invasion front has the most spectacular adaptations. Toads at the front there have evolved longer legs. There's been a strong selection pressure on dispersal ability. When toads first started expanding their range, they were moving at about 2 kilometres a year, and they're now moving at 50 kilometres a year. So that's a huge jump, and that evolution has happened in the span of one human lifetime. And those animals at the front line are under so much pressure for this high dispersal ability that they compromise on other aspects of their physiology, such as their immune system, and they actually develop arthritis at the front line. These adaptations have been in part been driven by habitat modification, which has allowed them to disperse and to kind of evolve this phenotypic, go down these phenotypic evolutionary lines. Habitat modification caused by us and by our practices. And today I'm going to talk about some examples of that. I'm going to give you references to pertinent literature, and I'm also going to talk about a couple of the interventions that we're playing around with here in Australia to try and mitigate the impacts of cane toads. Cane toads have adapted really well to urban environments, which is surprising for a large-bodied rainforest frog. And this is because there's lots of light as well as lots of water. So there's lots of food and opportunities for breeding in urban environments. The artificial light produced by street lights brings in lots of flying insects, and you often see cane toads huddled around the base of street lights, but also porch lights in the kind of suburban environment. And this is really pronounced in remote areas where there's less artificial light, because obviously more artificial light as well as bright phases of the moon dampen this effect of bringing in of the insects. So in remote areas, you often see toads, hundreds of toads huddled around porch lights, or like at our field base in remote northern Australia. There's cane toads always huddling around there to get close to those insects. Of course, the golf courses, sprinkler systems, botanic gardens, ponds are all very good places for toads to rehydrate, to breed, and so they do very well in the urban environment. And this has led to healthy toad populations that persist in high densities. Toads on the road. Northern Australia is characterised by vast tracts of land, and we have up there long stretches of straight, flat road. And toads have really keyed in on this as a resource for dispersal. They utilise roads more often and are able to disperse further along roads because they're a heavy-bodied species whose locomotor performance is impeded by dense vegetation. So toads will actually move along roads at night, and they will go off to the sides in the middle of the day when they're resting, and they'll come back onto the roads at night and continue their march. And they stay true to the direction of the road. This has led to an increased rate of dispersal and a couple of and there's a lot of roadkill on roads because of this. The Australian public has quite a disdain for cane toads, and people will purposefully swerve to kill them. But the populations are high enough that doesn't actually have an impact. And cane toad's toxin persists in their glands for many, many days. So if you're going to kill a cane toad, you really should be removing it as well. A couple of good refs to support this are up there, when we found out that they were actually using roads preferentially versus the adjacent woodlands. But also, cane toads at the front line have evolved a straight line preference for dispersal. Behind the front line in the range core populations, they kind of just move in whatever direction. But at the front, you could imagine there's extremely strong selection pressure for animals to move in a certain direction, which is basically westwards, which is moving into new, uncharted territory, more resources, etc. So toads at the front line have a very strong straight line dispersal pathway. And it's thought that these two aspects, this really strong capability for dispersal and this straight line dispersal, has in part driven their rapid movement across Northern Australia. Australia has a long history of pastoralism, basically since we've been here. It's even said that Australia was built on the sheep's back. 200 years of pastoralism history, we're very nostalgic about it, and we've used many species commercially in that time. Horses, cows, camels, donkeys, and more in the south, and the arid zone, sheep. But 30% of Australia or more is still utilised for pastoralism. The rangelands are particularly sensitive areas, and we still use them widely for pastoralism. The thing is that Australian ecosystems haven't evolved with the hard-hoofed ungulates within them. So they're very sensitive to impacts that they cause with the hard hooves, the heavy body. We've got smaller marsupial species. And as such, pastoralism has led to countless extinctions in Australia of our native fauna, but also facilitated the invasion of many other species through various means. And that's something that we call invasion meltdown. And pastoralism really has led to invasion meltdown in some areas of Australia. And I'm going to just go through a few of those impacts now. Large ungulates produce a lot of dung, and cane toads really key in on this as a resource. Large cow paddies are warm and they're moist, and they also attract a lot of insects, most notably dung beetles. Now, dung beetles were actually introduced themselves to try and mitigate the impacts of pastoralism. So our native dung beetles are not able to cope with the dung of these species, and so we introduced a range of dung beetles to do that. And cane toads really key in on that resource. They consume large amounts of dung beetles, and they're actually impacting the numbers of dung beetles in the environment and kind of counteracting that initiative that was taken to try and minimise the impact of feral ungulates. Warmth and moisture. We know that cane toads only can survive away from water for about 4 to 5 days. They're a thick-skinned toad, but they do still need some level of hydration, and they can actually hydrate off cow patties and horse patties, and they definitely do that. We've radio tracked cane toads to find this out through the desert, and so what we found is that the high amount of dung in the environment actually provides cane toads with year-round access to otherwise seasonal resources, which, as you can imagine, allows them to persist in areas that they wouldn't usually be able to. Grazing is probably the best known impact of the pastoralist industry. Grazing changes ecosystems dramatically, especially if you have no native grazers, ungulate grazers, which Australia doesn't. Grazing alters species composition and introduces weeds throughout the environment. It drastically reduces vegetation cover through direct grazing, but also through trampling. And as I said before, this vegetation impedes the movement of cane toads. And so this widespread decrease of vegetation across vast swathes of northern Australia would have allowed cane toads to move freely through the country. Ungulates also denude the edges of water bodies from vegetation, and they also trample them, and they muddy the water. And these are perfect conditions for cane toad breeding. Cane toads preferentially select sites for breeding that are no water movement, so not rivers, but dams, puddles. They can be murky. Native frogs will avoid that, but cane toads won't, and shallow edges and no vegetation. So it's perfect breeding conditions for cane toads. So this aspect of pastoralism really has enhanced not only toad dispersal, but the breeding opportunities for cane toads. And you can see this picture at the bottom there, the kind of densities that you can find around water points through the year. Of course, much of Australia is not really suitable for pastoralism, but we have tried there anyway. And to do so, we've had to create artificial watering points. Farmers will do this by sinking a bore into the ground, using a windmill in the top picture to pull water up, and they'll fill concrete troughs or dams. We call them turkey nest dams, and we actually build them up into a kind of a spout with the dam sitting right up the top. And as you can imagine, cane toads key in on this resource through the more arid areas in particular to rehydrate, to breed. They act as sources of invasion where cane toads can huddle in the dry season and then re-invade or continue their invasion through arid areas. And it's really these artificial watering points that have allowed cane toads to invade through and persist in environments that would otherwise be really undesirable to them. So in summary, the habitat modification, either caused directly by humans or as a consequence of some of our industry, has definitely led to an increase in the health and density of cane toad populations, increased breeding opportunities for cane toads throughout the range, increased dispersal ability through not impeding their movement and actually even providing roads and open pathways for them to disperse across Northern Australia. It's increased the rate and the range of expansion, the rate of expansion through those areas along some of those more open areas, and also the range into areas that we never thought they would be able to survive without things like artificial watering points. And also it's increased the inaccessibility for their control because they've been able to spread so far into areas that we wouldn't usually be visiting. And so, for example, the pastoralist industry in Northern Australia runs in a way where stations are gigantic in the millions of hectares, and there's just free roaming cattle across them, denuding areas, really decreasing vegetation cover, and then cattle are mustered by helicopters. So there's so much of that area you can't even get to really. And there are some control measures that can work on more of a local scale, but because cane toads have such a wide range, there's no possible way that eradication is even an option. It's just a picture here on the right-hand side of one of those control methodologies at the local scale. It's a cane toad trap that you can put into local water bodies, and you can check it, you know, once every few days, once a week, and it has really high success rate for pulling tadpoles out. And it's because cane toad tadpoles are actually attracted to their own toxin, because they have such strong selection and competition pressure, because they're so fecund. They're very sensitive to the toxin that the mother puts in the eggs, so they key in on the eggs and eat them. They're highly cannibalistic, but you can use that against them. An interesting thing about cane toads, and really a testament to their adaptability and success as an invasive species, is when you compare populations from different parts of the range, that they have adapted to the local environment very well. We've compared populations in Hawaii with populations in Northern Australia, and what we've found is the selection pressures that are in Australia are demonstrated by the phenotypic evolution that the toads have displayed, such as, you know, the high dispersal ability through vast tracts of land in Northern Australia. In Hawaii, though, you've got a lot of the islands are, you know, big parts of the island are just lava flows, highly undesirable habitat for toads, lack of water, not much food resources there. But then in between that, there's towns and there's also resorts, and with, you know, lots of water and lots of food. And so over there, cane toads have done the same thing. They've really keyed in on what resources are available to them, and they're doing surprisingly well in a place that's, you know, some of those places mostly made up of lava. So that's just a testament to their success as an invasive species and their adaptability. I'd like to mention now a couple of interventions that we are considering or have used, and based on their life history and the ecology, and some of those, some of the kind of keying into those modified habitats that I have just spoken about. We know that if you exclude toads from artificial watering points, that can act as a fairly big control over a region. You can see on the right-hand side and on the left the fencing that people put up around some of these artificial watering points. This works really well. It excludes toads breeding, and it really depresses local populations. But of course, you need to maintain those fences quite regularly. And following on from that finding and methodology that's been used, there's this exciting new idea at the moment that's getting legs, and it's aimed at actually containing the invasion. So we never thought we'd be able to actually halt the invasion anywhere, but some of my colleagues have discovered that so the invasion's moving in a westward direction. It's moving down the coastline, and it's moving into areas of high endemism, really important areas of high biodiversity. And what they've found is that on the west coast of Australia, the northwest coast, there's a region where the desert almost comes up to the edge of the coast. It's quite a narrow band. And most of the watering points through that region are artificial watering points, such as the one on the left. And what they've modelled is this idea that if you could close down those watering points, or if you could modify those watering points so that there was no freestanding water around them, then technically cane toads would never actually be able to cross over that region. They're pitching at about 100-kilometre region that they would need to modify the water bodies along, and technically cane toads would never be able to cross over that region in one wet season. Or that, you know, they'd make their way in and then they would die off in the dry season. So that's a really exciting idea that's based on what we know about their ecology and their interaction with these modified environments that we're providing. And as a follow-on from that, as a double whammy, what they're hoping to do is take these slow dispersal phenotype toads from back in Queensland, back in the core range, and bring them to just ahead of the invasion. They will outcompete the invasion front toads because they're generally much fitter for the environment than the invasion range toads, which are just all about dispersal. And then they will disperse that, the genetics, and hopefully slow the invasion down naturally to add extra oomph to that hydric waterless barrier. So that's just a couple of things that people are talking about, and I just raised that to show you some of the kind of innovative things that we're playing with. I myself don't work on population control or containment. I work on impact mitigation. I work with the animals that are impacted themselves, and I do this using a methodology called taste aversion. And Rick will explain this in a minute, and I'll talk more about it later.
Our native animals eat large cane toads and die from the poison. When they eat small cane toads, they get sick, but don't die. So when they see more cane toads of any size, they don't eat them. They have learned to avoid cane toads. However, at the cane toad invasion front, there are only large colonising cane toads. They don't breed at the invasion fronts. And this is where they have the most devastating effect on native animals. Our research has shown that adding small cane toads at the invasion front can teach the native animals to avoid cane toads before the large fatal ones come through. Our native animals can coexist with cane toads, but only if they know not to eat them.
It's basically food poisoning, and it sounds crazy that you may release an invasive species to mitigate the impacts of the same invasive species, but it's based on over a decade of research. And we know that all predators that are impacted have the ability to develop taste aversion, and so now what we're doing is actually rolling that out on the landscape scale. This is it in practice. This is an animal from my PhD, a large varanid species, which is very important in the ecosystem. And also important for Indigenous traditional owners as a bush tucker. So it's important that we keep them around. This is the first time it's met a toad, and it's a small toad. The toads that we use are non-lethal. And you can see that because it's a frog, he just gobbles it down. This is a subsequent trial with the same animal. And you can see that he investigates the toad. But eventually rejects the toad. And that's really what we saw in my PhD, that many animals were doing. The exciting thing was that animals learnt taste aversion after only just one experience with a small toad. But the more exciting thing was that once the cane toad invasion arrived, we saw a 50% increase in survival of animals that had been trained versus control animals that had not been trained, who essentially all died within 3 months of the cane toad arriving there. And the impact really is that severe when cane toads arrive in an area. So taste aversion increases the survival of these predators drastically. And what we're doing is actually rolling that out now in a big project ahead of the cane toad invasion. We do that with the Cane Toad Coalition, which is a group of organisations that I brought together representing a diverse range of stakeholders in the region that all have a vested interest in biodiversity preservation. And this is a really exciting initiative because these organisations often don't work together, or that they're their own entities. They don't need to work with other organisations, but we're working together to really leverage off each other's networks and skills and resources and knowledge. And so it's a really great conservation intervention initiative. We work with the Indigenous Ranger Network across the Kimberley as well, and they're pivotal to the success because they have such a deep knowledge of the seasons and of predator populations and country. It's really critical to the conservation strategy. These are a few of the species that we work with. The water monitors, which are heavily impacted in some areas. And the way that we deliver taste aversion depends on the ecology and the hunting strategies of the species that we're targeting. With water monitors, they live in rocky, gorgy habitat. So we either use the small toads, which we call teacher toads, or we use cane toad sausages, which are a meat-based sausage that has a nausea-inducing compound like a strong salt in it. And so we deploy that immediately ahead of the cane toad front so that animals have a strong learning experience very soon before meeting the cane toad invasion front. And then we come through and see how the populations are faring afterwards. We train crocodiles, wild crocodiles, believe it or not. We have developed a custom apparatus that we hang over the edges of water bodies because there's some populations of these predators that are really vulnerable because they're isolated. We use this apparatus to deliver the baits, and as you can see in the right-hand side, in the very right-hand side of the photo, you can see a crocodile reaching up to a bait to take it off, and that seems to be working really well. And what we're doing is just honing how we decrease the number of scavengers and things that come in, the nuisance species that we don't want to come and take the baits. And of course, the yellow spotted floodplain monitor, which, as I said before, is very important in the ecosystem. And we target these animals with the small teacher toads. We deliver those teacher toads to the riparian zones where these animals forage at certain times of the year. It also means that the toads are so small that they stay close to the water and they don't disperse any further than we would expect, and definitely not than the cane toads coming already. And yeah, these animals are able to learn and persist in the environment. So in Australia, we're really utilising a lot of methods to mitigate the impact of cane toads that have been iterative processes to get to these endpoints, and we're hopeful about the future. But really, you know, the cane toads, they have been our mess to start with, and as you can see, you know, we have done things along the way that have made it easier for them to invade. So we really, you know, it's a really big responsibility that we're taking to try and manage this species in Australia. Thank you.